All right, so in our last video, we talked about how to get rid of negative exponents in our final answer because negative exponents are not considered fully simplified. If we have negative exponents in our quote final answer, it's not final because we still need to do a little bit more work to get rid of those negative exponents. All right, so we can tackle a problem that looks like this by simplifying exponents, or simplifying an expression with exponents. In this case, there are some negative exponents thrown in, and that's okay, all right? So let's use all of the rules that we have already learned up to this point on how we deal with bases and exponents. So here we have 4 to the negative 2 multiplied times x to the 5th times 4 to the 3rd times x to the negative 4th. All right, so we see some common bases here. We see a 4 and a 4. These are common bases. When we have two bases that are the same, we call them like bases. So if you have like bases that are being multiplied, then you can add the exponents. So this would be 4 to the negative 2 plus 3. Okay, so I'm going to circle these guys. We've taken care of these two through adding the exponents, all right? And here we have two x's, all right? Like bases. Once again, what do you do when you have like bases and you're multiplying them? You add the exponents. So this is going to be x. So all this is times x to the 5 plus negative 4, okay? We can do a little bit more work with these exponents. Negative 2 plus 3 is positive 1. So that's 4 to the first power times x to the 5 plus negative 4. That's like 5 minus 4. That's x to the first power. So I would accept 4 to the first times x to the first. I'd accept that as an answer. But even better, because it's to the first power, you don't really need that one. It's implied that any number without an exponent is already to the first power. So really you can just write 4x. And that would be the best simplified version of this particular problem. All right, let's do another one. Again, we just use our properties of exponents, and just because they're negative exponents in here doesn't mean that that we can't use all of the same great rules that we've learned before. All right, how about this? What if we had b to the negative 5th times 8 times b to the negative 7th times 8 to the negative 3rd, okay? Let's try to tackle this one. So we have some like bases here, all right? The first thing that I would encourage you to do is if there's something without an exponent, remember it's implied that it was an exponent of a 1. So I can always put a little 1 right there. It might help me to do some of this math here. Okay, so b and b, these are like bases, all right? So I'm going to write b, the like base, and then we add the exponents. All right, so that's negative 5 plus negative 7, all right, times, and I'm going to circle these because we took care of them, and then over here we have 8 and 8, so we keep our 8, and then it's 1 plus negative 3, all right? So now let's simplify these exponents. This is going to be negative 5 plus negative 7 is negative 12, and 1 plus negative 3 over here, so base of 8, 1 plus negative 3 is negative 2. Okay? So this is a wonderful step on the way to becoming a complete answer, but it's not a complete answer by itself, in and of itself, because we still have negative exponents. All right? So what I'm going to do is to get a little bit more space here, I'm just going to erase our original problem. I'm going to rewrite this over here. All right? So it's going to be b to the negative 12th times 8 to the negative 2nd. All right, so I just rewrote that here, so I had more space. Okay, now, what we want to do is rewrite this so these exponents are not negative anymore, okay? So let's just, what if we just had b to the negative 12th? What if we just had b to the negative 12th? And that's what you had at the beginning, all right? Well, we could rewrite that, remember, as 1 over b to the positive 12th, right? Okay, so I'm going to circle this guy because we took care of it. And it's getting multiplied against. Remember, 8 to the negative second can be rewritten as 1 over 8 to the positive second. All right? So this is pretty good. I would probably accept this. There's a little bit more just to tidy things up. So this expression right here can be sort of simplified a little bit more. Again, this is correct, all right, and I would accept this as correct, but there's a way we can sort of bring things a little bit more in a tidy manner. So I would prefer to see 1 over b to the 12th, 8 to the second. Do you see how I could join these two fractions together through the operation of multiplication, which is what is happening over here? So I would prefer to see this as your final answer, which now does not have any negative exponents in it. All right, so in the next video, we'll just continue with these exercises and see if we can practice and get a little bit more familiarity and confidence with using negative exponents.